current which is to be get applied to that of pure capacitive circuit. What is the capacitance? Property of the capacitor by virtue of which opposes the storage of the charges in it. That itself is called as capacitance. Here E equal to Em into sine of omega t is applied to a pure capacitor which will cause the current which is to be flows I. Okay, whenever you are applied a voltage, what is the charge on it? Q is equal to C into V or the C into E. What is this E? Em into sine of omega t. So that current is equal to what? Change in charge with respect to the time. That is the rate of change of charges, dq by dt. What is Q? C into Em into sine of omega t. Differentiate with respect to t. C into Em into cos of omega t into omega. Okay, so that we can take this into reciprocal value at the denominator 1 divided by omega c into cos omega t will be represented in terms of sine of omega t plus pi by 2, because cos, that is sine, 90 plus theta is what? Cos theta, because it will comes under second quadrant. Sine is positive, then obviously cos of omega t. Okay, so that Em divided by 1 by omega c into sine of omega t plus pi by 2. Pi by 2 is how much? 90 degree. So that I is equal to Em into Em divided by xc sine of omega t plus pi by 2. Okay, Im is equal to what? Em by xc. That is the maximum current. Xc is equal to 1 divided by omega c. That is 1 divided by 2 pi f into c. That is called as capacitive reactance, which it is measured in terms of ohm, which is observed from the equation, from the voltage and current equation. Then whatever the current is there will leads the voltage. Current will leads the voltage by an angle pi by 2. Got my point? Okay, so that what happens with respect to the phasor representation? Current, whatever it is there, is leading the voltage by an angle pi. Okay, here voltage is 0. Already current is achieved maximum. It means current will lead the voltage. That is what the phasor representation. What is power? Power is the product of voltage and current. Okay, instantaneous power small p is equal to E into I. E equal to what? Em into sine of omega t. I equal to what? Im into sine of omega t plus pi by 2. Why plus pi by 2? Because current will lead by 90 degree in case of pure capacitance. Okay, what is sine into cos? Because whatever the sine omega t plus pi by 2 will be represented by cos of omega t. Okay, sine into cos is what? 2 sine 2 theta, sine 2 theta by 2. So that sine 2 theta into 1 by 2. That is 1 by 2 Em into Im into sine of 2 omega t. This is the what? The total amount of power which is to be required for the instantaneous power in case of the capacitance. But we need to make the evaluation of average power. We need to make the evaluation of what? The average power. The power which is to be get consumed by the pure capacitance, which to be get considered for one complete cycle. So that the average power consumed P is equal to 1 divided by 2 pi 0 to 2 pi into small p d omega t. Okay, 1 by 2 pi 0 to 2 pi Em into Im into sine of 2 omega t divided by 2. Okay, Em into Im, 2 into 2 is what? 4 pi. Integration of 0 to 2 pi. Sine of 2 omega t into d omega t. Integration of sine is what? Minus cos. Okay, minus cos 2 omega t divided by 2, because with respect to the omega t. So that cos 2 omega t divided by 2. What is this omega t value? 2 pi and 0. Cos of 4 pi by 2 plus cos 0 by 2. It is minus 1 by 2 plus 1 by 2. Okay, minus 1 by 2 plus 1 by 2 is what? 0. 0 multiplying to anything is what? 0. What is the our average power which is to be get consumed by the pure capacitance? Always 0. Okay, that is what? 0. What happening with respect to that? Okay, you have to draw the current waveform, then voltage waveform, power waveform. What happens? Both are the opposite to each other, so that the whatever the power is to be get caused, okay, by the power diagram, these two will get cancelled, because this is positive negative. What is the power? Is equal to 0. The power will get cancelled. The average power consumed by the pure capacitance is always 0. The average power consumed by the capacitance is always 0. Is this clear? No reply, no response.
Yes, sir.
At least one is respond. That is the happiest thing for me. Okay, no problem. It's your problem. You go through that. If you are brilliant, you can showcase your talent in external examination or internal. Okay, next with respect to the capacitive reactance Xc, the property of the capacitor by virtue of which opposes the flow of current through it. That itself is called as capacitive reactance. Okay, whatever the current which is flowing through the capacitor will be get opposed by the property. That itself is called as capacitive reactance. Okay, that is also be called as the opposition offered by the capacitance for the flow of current through it, or the capacitor. That itself is also be called as a capacitive reactance, which to be represented by Xc and is measured in terms of ohm. Then capacitive reactance Xc is equal to 1 divided by omega c, okay, which is measured in terms of ohm. Okay, that is what? Omega equal to 2 pi f, x is equal to 1 divided by 2 pi fc. Whatever f is there, okay, that is the frequency of the applied voltage in terms of hertz. Then capacitance is what? C in terms of farad. Then the last content is what? Impedance. What is this impedance? The total opposition which it is offered by the resistance, inductance and the capacitance combination for the flow of electric current is itself is called as impedance, that can be represented by Z and measured in terms of ohm. Okay, the next topic with respect to that of single phase AC circuit. For the series AC circuit, that is series RL circuit, then RC circuit, RLC circuit, then parallel RL circuit, RC circuit, then RLC circuit. Okay, these things will also be plays a very important role for the examination point of view. Is this clear? For pure resistance, pure inductance, and pure capacitance. Any doubt?
Yes, sir.
Once you go through that, the content, okay, if you are getting any doubt, then you can ask. Okay, I will repeat here. For pure resistance, voltage and current are in phase. Okay, then what happens? Power factor is equal to what? 1. Okay, P is equal to what? V into I. In case of the inductance, what happens? Current will lag voltage by how much angle? 90 degree. Isn't it? Then what is cos 90? Cos 90 is how much?
0.
Anyone
Zero.
reply? 0. Isn't it? What is power consumed by pure inductance? VI into cos
Zero.
pi na? So that the average power consumed by the pure inductance is 0. But you have to derive by this analytical method. Okay, don't follow this method. Okay, this is I am giving the instruction with respect to that of whatever power which is get consumed by the inductance is 0. Then with respect to the capacitance, what happens? Current will lead. Current will lead voltage by how much angle? 90 degree. Okay, what happens with respect to cos 90? Here is also 0. What is the power which is get consumed? Is also be 0. Okay, this is you have to remember. Don't forget at all. What is the power in equation for pure resistance? The product of the RMS value of the voltage and current. Why? Cos pi equal to 1. Is this clear now? In phase, out of phase. Remember it. In case of inductance, current will lag voltage. In case of capacitance, current will lead voltage. If it is a pure inductance, by 90 degree. If it is pure capacitance, by 90 degree. Resistance, current and voltages are in phase. What is impedance? Impedance is the total opposition which is offered by the resistance and the reactance. That itself is called as impedance. What is the equation for XL? XL equal to 2 pi FL. X is equal to 1 divided by 2 pi FC. Okay, what is the unit for inductive reactance? Ohm. What is the capacitive reactance? Ohm. Is this clear now? Anybody is